So in this video we're going to try to prove product rule. So what do we know? If we were supposed to do a derivative of this product function, I'm saying product because there is multiplication here in between, we would have said we derive the first one, which is going to be f, and put h as it is, plus now we derive h, and then we put f as it is. So this is the product rule. Product rule says this. Let's put it here. So we are required to prove this. We are going to use our first principle. So we are going to say, okay, let me just first write the first principle. It says limits as h approaches 0 should equal, now equal sign is on the other side, and then we're going to, you take a function, you put x plus h, and then you subtract the function at x, and then that all should be all over h. Okay, so this is our first principle. Let's apply the first principle here. Let me bring back the dots, it's better with the dots. So it's going to be like this: limits as h approaches 0 of the function. This is the function, so wherever there is x, we put x plus h. So it's going to be f x plus h, x plus h. Okay, so then we subtract the function itself, f of x, h of x. This is the function, and that is still all over h. If you notice very well, this is the same as this one. So let's keep working. So what can we do here? We're going to do something that is I'll say it's what you need to put in your head about proving this. You're just going to add something and subtract that thing again. So that means you won't change anything on the problem. So right now I'm still copying the thing that is on top, x plus h. Then I'm going to add I'm going to subtract a term, f x plus h, and f at h, and then put the term back. So that means I've done nothing, no work done in the problem, so displacement is 0. Okay, so sorry about that, and we're going to put exactly what is here, come back here. Oh no, I have h, and then minus fx hx. Okay, so this is still all over h. So the only thing clever that we have done here is adding this term and also subtracting the term. All in all, this thing is the same as this one again. So this changed nothing on the function. So let's start working again. Limit, okay, limits as h approaches 0. Okay, now we can notice that we from these terms we having something called common factor here. Okay, and what is common is this is common here and here. We can take it out, right, and we'll have x plus h. I'm taking it out, and if I take it out here, I'll have h x plus h, and if I take it out here, I'll have minus h x. Close. Okay, let me move my stuff here. Okay, so now, and also this side I have something common. This is common from these two terms. Okay, what is common there? I said it was plus hx, and if I take it out from here, I'll have x plus h, and if I take it out from here, I'll have minus f at x. Close. Okay, this is all over h, so I can just take h for this term and h for this term. So I'm just saving time. I should have shown the step all along, but it's just nothing. I just take h, put h there, and put h there. So h is for both of them. It's common denominator, it can come back to here. So I haven't done anything clever yet. And then limit as h approaches 0. I'm going to use limit laws to take limit for this part, and limit of this part. So I'm going to take limits for each term. So from here I can now say that let me just do it like this. I'm just skipping a lot of steps. If I'm looking at this term, as h approaches 0, this term will become f of x. Okay. If I take limits as h approaches 0 of this term, now look this carefully, of this term, this thing, we know this thing is almost same as the first principle. So if you notice, if we were supposed to take the limit as h approaches 0 of h of x, we would have given this. So this is the same as, let me just remove this up, or I'm already taking from limit. So let me just use equal sign. This is going to be the same as derivative of h of x. And plus, let's come back here. I'm using the limit law that says product of the product of the limit is the limit of the product. That's why I'm doing this, but I'm just skipping a step because I assume by now you can do that. I'm just showing you how to do it. Okay, if we're taking limits as h approaches 0, there is no h here, so h won't change. It's more of like it's a constant. Let me just put it outside. And here, if I'm taking this as h approaches 0, this is the same as taking the derivative of this. So I'll have plus on a plus. There's just dots. Okay, then that will be taking a derivative of f of x. And if you notice very well, this is strictly the same as what we were required to prove here, where we did it, to prove here. So we have achieved what we required to prove. So this is what the product will state.